Hello everyone, my name is Natalie, and I am here to provide a brief demonstration of the tools developed by the Road Safety Research Team at UBC. These tools were designed to gather information related to cyclist and pedestrian accidents in the province of British Columbia. First, we will start with a brief introduction to the dataset that we will be using for the evaluation. This dataset was obtained from public available data from ICBC. The ICBC dataset initially had 1,048,562 records and was provided in CSV, separate values format. After filtering the accident related to pedestrian and cyclists and cleaning the database, we were left with a total of 10,002 accidents involving pedestrians and 7,249 accidents involving cyclists. We applied a filter to select only those records with geographic coordinates. We ended up with 8,328 rows representing accidents involving pedestrians and 5,915 records representing accidents involving cyclists. These records were then converted to a shapefile format and will be used as input for the upcoming tools we are going to present. Next, we generate a URL for each accident location, using the power of Google Street View to visualize the scenes clearly. This allows us to make use of the coordinates and functionalities of Street View for a more comprehensive understanding of the accident sites. Now we have a functional dataset. We create a web map that allows us to visualize the points we initially had in CSV format. Furthermore, this map directly links us to the Street View scenes, enabling us to understand the environment's characteristic of the accident's date. We developed a survey form that allows us to record this visual for each point visualized in Street View. Okay, let's focus on the core of our research, the survey. We use Survey 123 Connect to design a customized survey, collect crucial information about the accident environment. The survey questions were categorized in 4 groups. 2 are related to the accident location, intersection, or along the road, and 2 are related to the involved party, pedestrian or cyclist. For demonstration purpose, I will evaluate 4 specific points using the survey tool functionality. In this section, we will explore the functionalities of the web map interface. Legend. The legend displays colors corresponding to attributes on the map. The layers panel shows the available layers on the map. The search feature allows searching by accident ID. You can choose a preferred base map. The map represents survey response categorized into 4 groups related to road users and accident locations. To provide an accurate description of accidents, we need the accident year and coordinates, now linked to Google Street View. Clicking on a point takes us to Google Street View. We select the nearest date, explore the area, and answer survey questions. You can open the survey in a web browser by clicking the map icon in the upper right corner or by using Survey 123 app. We begin by answering general questions for each point, which relate to the number of lanes and the presence of street parking or adjacent parking lots. We have 4 possible response scenarios. In the first case, when the accident happens at an intersection and the involved road user is a cyclist, the survey will restrict the available response options as we can see here. Now, let's consider the example where the individual involved in the accident is a pedestrian, and the accident occurs at an intersection. We can see how the group of possible response options change in response to this new choice. In this scenario, we are evaluating an accident that doesn't happen at an intersection and involves a cyclist. We can see the group of responses that become enabled. In our last scenario, we'll examine a non-intersection pedestrian involved accident and the associated response choices. Now that we understand the basics, let's move on to practical examples. First, we randomly select a blue point, which, according to the map symbols, represents cyclists. We visually navigate the map to find an intersection. We enter the accident ID into the survey form. As mentioned before, we check the year of the accident. Then we click on the Google Street View link, searching for the image closest to the accident date, and we perform a general pan to describe the environmental characteristics at the time of the accident within the survey. We describe the intersection features based on what we observe in the Google Street View scene. Since the accident involves a cyclist at an intersection, a specific response becomes available. We carefully examine the surroundings to answer the survey question as accurately as possible, based on what we observe. Let's now evaluate an accident that occurred at that intersection and involved a pedestrian. We select a red point that represents pedestrians at an intersection. We follow the same previous process, starting by entering the accident ID into the survey form. Checking the accident year, selecting the image close to the accident date, and conducting a general pan to describe the environmental characteristics at the time of the accident. Since the accident involves a pedestrian at an intersection, specific response options become enabled. As a third example, let's consider an accident that didn't occur at an intersection and involves a cyclist. We select a blue point that isn't located at an intersection. We follow the same precedent process, entering the accident ID into the survey form, checking the accident year, selecting the closest image to the accident date, and conducting a general pan to describe the environmental characteristics at the time of the accident. We describe the surroundings features based on our observations in the Google Street View scene. Since the accident happened along a road and involved a cyclist, specific response options for this case are enabled in our survey. This time, I want to demonstrate the functionality of the search. Let's say we know the accident ID number that we want to evaluate. We select the magnifying glass icon, then click the arrow. This will open the search option. We select the layer ICBC crash, input the accident ID we are looking for, and then click on the Zoom to option and select the highlight point. This point represents a pedestrian involved accident that didn't occur at an intersection. We repeat the same process and send the results. Results are stored directly in the cloud, allowing easy access. In essence, we are performing a join by accident ID between the survey results and the initial point layer. This creates a comprehensive dataset that combines information from ICBC and the collect survey data. Another way to visualize the results is directly on the Survey 123 web platform. In real time, we can observe statistics related to the number of evaluate points and the distribution of their responses. Additionally, it is possible to visualize the responses in a data table